Hello students, today we will learn geometric transformation and different types of geometric transformations. So now first we will understand what exactly the geometric transformation. So with the help of this we will understand geometric transformations. 2D computer graphics is the computer based generation of digital images mostly from two-dimensional models such as 2D geometric models, text and digital images and by techniques specific to them. So it facilitates ease in alteration of different images on drawings which is called as transformations. So transformation is a graphical concept of software module used in CAD CAM that produce the functionality and interactivity of the system. Geometric transformations moves point in a space from one location to another, or they change the description of a point from one coordinate system such as WCS to another system such as MCS. So in general, it can be defined as the change done to the database by performing certain mathematical operations on it so as to produce the desired change in the image. So simply we will understand geometric transformation with the help of this definition. So it can be defined as the change done to the database by performing certain mathematical operations on it so as to produce the desired change in the image. So you know that initially we have learned how to draw the point, then how to draw the line, circle. So different things we have learned. So now if you observe here in computer graphics, whenever you draw a certain object, so in that case we want to do certain operations like somewhere we draw the line but we want to move it from that position to another position. Similarly, somewhere we want to uh, change the size of that particular drawing, either reduce the size or either uh, increase the size. Also, we want to somewhere we want to rotate that drawing. Okay, so like that, so different changes there are the required. So that can be happen with the help of certain mathematical operations so that desired change can be obtained in that particular image. So in simply you can say that geometric transformation is the repositioning or resizing of an object. Here are the some of the major transformations. You can set different types of geometric transformation starting from translation, rotation, scaling, reflection, or you can say mirror, and last is shear. So now one by one we will see in detail. So first is translation. So that all are mentioned here. Translation, here you can observe translation, rotation, scaling, reflection. So reflection is also called as mirror. So first we will start with translation. So here you can observe that in translation there is you can say that the object is moved from one position to another position. In rotation, object is rotated. Then in scaling, their size is change. So either it may be reduction or it may be enlargement. Then reflection like mirror. So all these things are shown in here. So we will see one by one. So first is translation. When every entity of geometric model remains parallel to its initial position, the transformation is called as translation transformation. Translating a model implies that every point on it moves by an equal distance in a given direction. That is, translation means simply you can say that moving object from one location to another. So, for better understanding purpose, we will consider a two-dimensional point having coordinates x, y. Okay, so therefore P is equal to x, y. So translate point P by distance Tx in x direction and Ty in y direction. So translation matrix T is added to the original matrix. So original matrix P is equal to xy. Translation matrix is t is equal to tx and ty. Suppose p be the new point, p dash be the new point having coordinates x dash and y dash. So mathematically we can write p dash is equal to original matrix plus translation matrix. So that is p dash is equal to p plus t. So matrix will be x dash y dash is equal to xy plus tx and ty. So this is the translation. So simply in translation we move the object from one location to another, and mathematically we have written the equation for it. Then next is rotation transformation. So rotation transformation helps in angular change in the body with respect to some fixed point. So rotation of any point is effective with respect to some fixed point. So in this study we will assume anti-clockwise rotation as a positive and clockwise rotation as a negative. So now let's see the basic equation and transformation matrix along different axes. So here we have drawn the diagram. So that consists of x-axis. So this is your x-axis, here is your origin, and this is your y-axis. So if you see here, so here we have considered point P. This is the point P having coordinates x and y, and this point P is having distance r from this origin. So here is the origin O. So from the origin point P having distance r, so this is the distance r. So that makes an angle phi with x-axis. So this point P is rotated in anti-clockwise direction. So in this direction the point P is rotated, and it takes a new position P dash. So its coordinates are x dash and y dash. Same distance r is there. So this is the rotation angle theta. So now here from this diagram we will write x is equal to r cos of phi, y is equal to r sin of phi. So we have given equation 1 and equation 2. Then similarly x dash is equal to, we can write r cos of phi plus theta. So if you apply cos of a plus b here, so you can write x dash is equal to r cos of phi into cos of theta minus sin of phi into sin of theta. Okay, when you solve this bracket, so you will get r into cos of phi into cos of theta minus r into sin of phi into sin of theta. So from 1 and 2, x dash is equal to x cos of theta minus y sin of theta. So we have put the value of r cos of phi, so that is x. Similarly r sin of phi, that is y, and rewrite the equation. Then similarly y dash is equal to r sin of phi plus theta. We will apply basic trigonometric equation sin of a plus b. Okay, so we will expand that bracket, and finally we will get y dash is equal to y cos of theta plus x sin of theta. So that is equation number 4. So from this figure we already learned, so this equation we have write 1 2 3 4, and in matrix form we have written x dash y dash is equal to cos of theta minus sin of theta cos of theta into xy, where p dash is equal to r into p, so where r is the rotational matrix. Okay, so this is your rotational matrix. So in this way we have completed the rotation transformation. Now next is scaling. So in scaling transformation alters the size of object. This is very important. So in scaling we can reduce or enlarge the size of the object. So scaling can be uniform, so that is equal in both x and y direction, and second is what, non-uniform, that is unequal in both x and y direction. So scaling about the origin can be achieved by matrix transformation of the form. So x dash is equal to x into sx, y dash is equal to y into sy, this is sy. So sx is the scale factor in x direction, sy is the scale factor in y direction, and s is the scaling matrix. So the above equation can be written in matrix form. So x dash y dash is equal to xy into sx 0 0 sy. So this is the scaling matrix. So this is the example of scaling. So this is the x-axis, y-axis, and here is the origin. So this is the original position, or you can say initial position having coordinates p1 p2 p3, And suppose we enlarge this triangle, so this is the new position, or you can say scale position, and here you can see new coordinates p1 dash, p2 dash, p3 dash. So this is the enlargement of scaling, so you can see the scaling. So you can perform any operation, either you can enlarge or reduce the size of the object. So next is reflection, or you can say mirror. So it produces a mirror image of the graphics element about any axis or line, about any axis or line. So in general, p dash is equal to p into m. So this is the equation. So where p dash is equal to new position, p is the initial position, and m is the mirror matrix. So commonly used reflection are, so different types of reflections are there: reflection about x-axis, reflection about y-axis, reflection about origin, reflection about line y is equal to x, reflection about line y is equal to minus x. So these are the five commonly used reflections are. So now one by one we will see in detail. So here reflection about y-axis. So about y-axis, we have seen already equation p dash is equal to p into m. So p dash is the new position. So how we will get new position when you multiply the p into m. So p is the initial position and m is the mirror matrix. So in this all the five types consist of the mirror matrix, so that is different. So here reflection about y-axis, so here you can observe, here is your origin, this is your x-axis, this is your y-axis. So this is the object, so this object is reflected about this y-axis. So in that case mirror matrix is minus 1 0 0 1. Similarly reflection about x-axis, so about this x-axis reflection is happen. So this is the initial position and this is the final reflected position. So in that case mirror matrix will be m is equal to 1 0 0 minus 1. This is the reflection about origin. So in that case mirror matrix is minus 1 0 0 minus 1. Now next is shear transformation. Shear transformation distorts the shape of the graphics elements or object. So basically there are two types of shear x direction shear and y direction shear. So now we will see in detail x direction shear and y direction shear. So this diagram shows shear in x direction. So initially you know that this is the x axis, this is y axis, this is origin, and here is certain object having point P and its coordinates x comma y. So when you apply the force in x direction, when you apply force here about this point P in this x direction, so what will happen? This P changes to P dash, so new position will happen. So this diagram shows the before shear and this diagram shows the after shear condition. So here you can note that there is no change in y direction, only changes happen in x direction. That's why it is called as shear in x direction. So in this case we can write equation in mathematical form: x dash is equal to x plus shx into y, and y dash is equal to y because there is no change in y direction. So where shx is the shear parameter, and this equation, this above equation we can write in matrix form. So x dash y dash is equal to 1 shx 0 1 xy. So p dash is equal to ssx into p. So this is the SSX is what? Shear matrix. So this is shear in x direction. So mathematical form you can write in this way. Now here shear in y direction. So again two diagrams we have considered. This is diagram A. So before shear, and this is diagram B after shear. So as usual this is x axis, y axis, and this is origin. So here initial point P having coordinates x, y. So suppose we apply force in this direction in y direction. So you can see there is new position obtained p dash x dash y dash. So in that case x dash is equal to x because there is no change in x direction. Y dash is equal to y plus hsy shy into x, where shy is the shear parameter, and above equation can be written in matrix form: x dash y dash is equal to 1 0 shy 1 xy. So p dash is equal to shy into p. So in this way you can find out shear in y direction. So I hope that you have understood all these geometric transformations. So all this summarizes here: translation, rotation, scaling, reflection, and shear. Thank you.